Alright, Unit 3 starts involving a little bit more complicated derivative rules, like the chain rule and implicit differentiation, and then this rule for finding the derivative of the inverse. And so a lot of these things, you'll be able to look back and see the rule. You just need to make sure you can use it. So for this first one, we have a table that contains values for f and values for f prime. And we're going to use it to do several different things. So for the first one, it tells you that G is f inverse. And we know some things about, well, we know one thing about G, that G of 1 is 3. So I am going to write down the formula for finding the derivative of an inverse. And this is one you guys seem to remember really well, but it doesn't matter because you'll be able to look it up. But if you remember it, then it'll save you some time. So we do 1 over and then f prime of f inverse of x. Alright, so we know that g of x is f inverse of x. So what that means is g of 1 equals 3. So also f inverse of 1 equals 3. So we need to go ahead and change this. We want to find g prime of 1, which is the same as f inverse prime of 1. So what we could do is take that formula and in the place of x, go ahead and put 1. Alright, we just found that f prime, or f inverse of 1 is 3. So in the place of f inverse of 1, we're going to go ahead and put 3. Okay, and then we want to find f prime of 3. That we go to the table. Here's f prime, here's 3. F prime of 3 is 2. So in place of f prime of 3, we're going to put 2, which makes g prime of 1 equal to 2. Alright, so all the information is there. You just have to sort through it. And sometimes it's hard when it tells you g prime is f inverse, and you have to kind of sort through all that on your own. So what I did is I just wrote that g prime was f inverse, and everything that they told me about g, I just changed it to f inverse. And then it helps me use my formula. Okay, this next one I thought was kind of fun, but I'm weird. So we have another function, h, and it uses f kind of in a weird way. So it's the composition of f and f of 2x. So we want to find h prime of 2. So we need to find h prime of x, which means we have to use the chain rule a couple of times. So we have a function inside of a function inside of a function. So we start with the outside function, and we're going to do f prime, and then leave the inside alone. And then multiply that by the derivative of the inside, which is f prime of 2x. And then we multiply that by the derivative of 2x, which is 2. A lot. Alright, then we can go ahead and put in our 2. So 2 times 2 is 4. 2 times 2 is 4. Okay, and then we'll just slowly start finding these values using the table. Alright, f of 4 is 1. F prime of 4 is 5. Okay, f prime of 1 is negative 3. So we have negative 3 times 5 times 2, which is going to be negative 30. Isn't that fun? Okay, once you get past that first chain rule, then it's just kind of finding what you need. Okay, I remember telling my husband that was fun, and then I got to this and I was like, that wasn't as much fun. So, it is okay. We can do this. So for C, we have a new function K. And I don't even think we use the table, but maybe we do. So K is 2 times the inverse tangent of e to the x. And we're going to figure out what value of x in that interval from 1 to 4 is the instantaneous rate of change equal to the average rate of change. Okay, so finding the average rate of change is not too terrible. Oh, we do. It's average rate of change of f. So the average rate of change of f, we go to the table. And it's going to be f of 4 minus f of 1 over 4 minus 1. All right, f of 4 is 1. F of 1 is negative 2. So we're going to go 1. All right, and then we want to find the instantaneous rate of change of k. And remember, instantaneous rate of change is the derivative. So this is a difficult chain rule problem for a couple of reasons. Now that I realize that you're going to be able to look at, rules and stuff, it might not be as difficult for you, but you do need to know the derivative of the inverse tangent or be able to find it. And then we'll have to use that and apply the chain rule at the same time. So, sorry over here, that dx of the arc tangent or inverse tangent is 1 over 1 plus x squared. All right, so we have to use this one. So that 2 is just going to go on the top. We don't have to really worry too much with it. In the place of x squared, we have to put in our e to the x. And because this wasn't just x, it was a different expression using x, we have to multiply by the derivative of e to the x. And the derivative of e to the x is e to the x. All right, and we technically could leave it like that, but since we have to use it in a second, I would just simplify it down a little bit and have it 2e to the x over 1 plus. And then when we have a power raised to a power, we multiply those powers together. All right, now the whole point of this question is we want to find what value of x does the instantaneous rate of change of c equal the average rate of change of f. So we need to find where these two are equal. All right, and so then I'll just go ahead and multiply. All right, and then I'm going to get everything on one side and kind of put it in descending order. All right, and then I realized this is kind of a fun problem because we get to use some algebra, some kind of weird factoring that we did in pre-calculus. I actually remember doing ones like this where it's e to the 2x and then the middle term is just e to the x, and we're going to factor it with e to the x and e to the x. Our signs are the same in both subtraction, and we want to multiply to get 1 and add to get 2. It's going to have to be 1 and 1. So these are the same factors, so we just need to set one of those equal to 0. Move the 1 over. All right, and then we figure out e to what power gives you 1. and that power has to be 0. So it started off kind of strange doing the chain rule with an inverse tangent function, but it ended up not being too terrible. Okay, and then this last one, we first going to find the second derivative of k to the x, and then we're going to evaluate it for 0. So we'll take that k, the first derivative of k, and looks like we're going to have to do the quotient rule. So we'll change that to the second derivative. We're going to do low d high, and it is going to be its own derivative, minus high d low. So the derivative of 1 is 0. The derivative of e to the 2x, we have to be careful. It is e to the 2x, but since our power wasn't just x, we have to multiply by the derivative of that. And then over low squared. All right, and I honestly would leave it like this. Unless they tell you to write it in simplified form, I wouldn't worry about it. We're going to fill in 0, which means we're going to get a whole lot of 1s and a whole lot of 2s, and that's it. So I would just go ahead at this point and plug in 0, because if I start multiplying and simplifying, it's just going to create places for us to make a mistake. Okay, so we're going to get 1 plus 1 times 2 minus 2 times 2 over 1 plus 1 squared over 4 minus 4 over 4, which is going to be 0.